of section 2.5, we are going to look at finding z-scores when we are given a data set. So this time we won't just be given the mean and the standard deviation. So for our first problem, the mean salary for a sample of electrical engineers is 83,000 with a standard deviation of 1,500, and this data set has a bell-shaped distribution. We want to use the empirical rule to estimate the percent of electrical engineers whose annual salaries are between $80,000 and $86,000. So if we sketch the distribution, right in the center will be our mean, which was given to us as $83,000. And if it has a standard deviation of $1,500, we can add that standard deviation to the mean once to get our first value, and again to get our second value. And then subtract to get our standard deviation values in the opposite direction. So here we have 81,500, and here we just have 80,000. Right? So using the empirical rule that says that 95% of the data falls within 2 standard deviations of the mean, right, our answer to part A would be 95%. Now in part B, we want to find the z-score of these values. So I want to find the z-score of $80,000, and I want to find the z-score of $86,000. Alright, so the z-score for $80,000, let's use our z-score formula. Substituting the values in, my x this time will be the 80,000. Right, mean, going back to the original problem, the mean is 83,000, and the standard deviation is 1,500. So this has a z-score of -2. And the data value of $86,000, substituting into the z-score formula, we have 86,000 minus 83,000, all divided by the standard deviation of 1,500. This time we have a z-score of 2. Now this verifies our result to part A because the empirical rule tells us that 95% of the data falls within 2 standard deviations. And now looking at part B, we can see using z-scores that these values go from a z-score of -2, this 80,000 on the graph, a z-score of -2, to a z-score of +2 for the $86,000 on the graph. Right, so in our first example, we have 10 randomly selected students were asked how many text messages they send in a day. All right, the results are 73, 65, 20, 0, 17, 80, 85, 125, 6, and 75. So we want to find the z-score and describe the relative position of the value 85 in the context of this problem. Right, now they just give us a data set, and we need to use the calculator to find the mean and the standard deviation. And when I'm looking at this situation, this is just a sample. So when we use the calculator, we're going to take the sample standard deviation. So go to stats on your calculator. If you have some values already typed in your calculator, go up to L1, hit clear and enter, and then we'll type in our data values. They are 73, 65, 20, 0, 17, 80, 85, 125, 6, and 75. So I hit stat again, go over to calculate, one variable statistics, and hit enter again. So my mean is 54.6, and the sample standard deviation is 41.28, or I'll round that up to 0.29. So going back to our problem, we're going to say that we're going to approximate the population mean. We're going to approximate it using our sample mean of 54.6, and we're going to approximate our population standard deviation using a sample standard deviation of 41.29. So if we want to find the z-score and describe the relative position of the value 85 in the context of the problem, our data value is going to be 85. So set up the z-score formula, x minus mu, all divided by the sigma. Right, substituting our values in, we have 85 minus 54.6 divided by 41.29, and that gives us a z-score of 0.74. So in the context of this problem, this person sent a little more text messages than average. A z-score of 0.74 is a little more than the mean, so it's a little more than average, but it's not unusual. So this person sent a little more than the average number of text messages. Then in part B, suppose you sent 45 text messages yesterday. What is the z-score of this data value? And what does this mean in the context of the problem? So now our x value is 45. When I substitute that into the z-score calculation, I have 45 minus the mean, which is 54.6, all divided by the standard deviation, 41.29. This z-score is negative 0.23. So in the context of this problem, you sent a little less than the average number of text messages. The negative z-score means less, and it's only a negative 0.23, so it's not much less than average. In example 2, 15 randomly selected teens with jobs were asked how much money they spend shopping online each month, and we see the data values from those results. So in part A, we want to find the z-score and describe the relative position of the value 100.08 in the context of the problem. All right, now using my calculator again, I approximated the population mean using the sample mean, and that sample mean was 69.08. Then I approximated the I approximated the population standard deviation using the sample standard deviation, which was 24.9. In part A, our data value is 100.08, so using our z-score formula again, z equals our data value minus our mean divided by the standard deviation. We have 100.08 minus 69.08, all divided by 24.9. Our z-score comes out to 1.24. Right, so this person spent more than the average amount online shopping each month, but it's still not an unusual amount. Right? It's still within 2 standard deviations of the mean. So now in part B, suppose you only spent $29.99 online shopping last month because you are saving up for Christmas shopping. So what is the z-score of this data value, and what does it mean in the context of the problem? So now our data value is 29.99. Again, going to our z-score and substituting the values in, we end up with 29.99 minus 69.08 divided by 24.9. So the z-score of your amount spent is negative 1.57. So in the context of the problem, you spent less than average online shopping. Last month. But it is still a usual amount. Right? It's still within 2 standard deviations of the mean. Alright, so now go on to the practice problem, try that practice problem, and then in the next video you will have the solution.